Hello and welcome everyone to episode 29, Remastered. Today I'll be exploring the Holocene, the most recent division in biological time, and the world of ancient man. The Holocene is by far the shortest of all of the geological eras that I've explored so far. The first geological era was the Precambrian, which lasted for 4 billion years. For the first 2 billion years, the Earth was forming in a chaos of volcanic fire and asteroid smoke. Then, the first cells appeared, slowly evolving over the next few billion years. In time, some cells integrated with mitochondria and became able to produce enough energy to support a more complex internal biochemistry. Some of these cells also integrated with chlorophyll, becoming photosynthetic. Multicellularity was evolved, leading to the Cambrian explosion 541 million years ago. During the Paleozoic era, the oceans filled with life of all sorts, from bacteria to plants to animals. Marine ecosystems emerged, and life became increasingly complex. After nearly 75 to 100 million years, life crawled onto dry land. The microorganisms came first, and they were followed by plants and arthropods. The tetrapods came later, evolving into the ancestors of mammals and reptiles and amphibians. In the ages beyond 300 million years ago, in the heart of the Devonian, the Carboniferous, and the Permian periods, the dry land masses of the Earth were covered in complex ecosystems. As time progressed into the Mesozoic era, things like giant dragonflies, predatory marine reptiles, and the dinosaurs dominated the planet, until a massive asteroid struck the Earth and wiped out almost everything. Birds and mammals would come to be the dominant forms of life in the Cenozoic era. In the case of terror birds and saber-toothed tigers, many of these species grew to terrifying proportions, replacing the dinosaurs as the dominant predators in most ecosystems. During the Cenozoic, the world's climate became drier and colder, going through several cyclical periods of glaciation, where the polar ice flows reached as far down as 40 degrees in latitude. These changes led to the widespread emergence of grasslands and savannas, to the spread of deserts and the regression of forests. Our primate ancestors saw the writing on the wall, and they moved out of the jungles and into the plains of eastern Africa. The early Homo sapiens would spread north out of Africa, going east into Asia and north into Europe. These groups of Homo sapiens encountered populations of Neanderthals that had dispersed from Africa thousands of years before, and they traded with them, bred with them, and eventually drove them to extinction by outcompeting them. These human populations would continue to migrate, with those in Asia continuing eastward to the coasts. They moved north, through Siberia and across the Bering Land Bridge and the Kelp superhighway that connected Asia with North America. The relatively high quantity of ice that was tied up in glaciers had lowered the sea level, and the Bering Land Bridge was exposed for several thousand years. Early human groups migrated across this land bridge and moved south, settling North America and then South America. These migrations out of Africa began around 100,000 years ago, and took another 40,000 years for population groups to fill out the Asian continent. They crossed the Bering Land Bridge and the Kelp superhighway sometime, most likely around 16,500 to 20,000 years ago, and this would finalize the settlements of all the continents except Antarctica. All of these migrations occurred at the end of the Quaternary Period, at the end of the Pleistocene, at the end of the Cenozoic era. This time period was characterized by a series of ice ages, which involved the formation of glaciers that were so large and so extensive that they disrupted ecosystems and obstructed travel corridors. The last of these glacial events began around the same time that Homo sapiens began migrating out of Africa. This glacial period would last for about 100,000 years, with glaciers moving down from the poles, peaking in size about 22,000 years ago, and then receding. This glacial period ended 11,700 years ago, which was the beginning of the Holocene. Even though the Holocene is a relatively short period of time, barely more than 10,000 years, and because it's the most recent period in geological time, the Holocene has been extensively studied. We have a really informative window into the past, into the early Holocene, because many samples of plant and animal tissue have been preserved. Not that many have been lost or destroyed. This biological material tells the story of the Holocene, revealing a tapestry of extinction, climate fluctuations, and an increasingly profound human influence on the natural world. Because of the short time span of the Holocene, plants and animals didn't really evolve very much, and the continents have moved less than a kilometer. The biggest changes in the biology of the planet involved the migration of various species into new areas, including the migration and blending of human population groups, and because of humans, the extinction of species like the woolly mammoth and the saber-toothed tiger. The climate fluctuations are an unofficial guide used to divide the Holocene into 5 blocks of time, each one lasting about 1 to 3,000 years. In chronological order, these 5 periods of time are the Pre-Boreal, the Boreal, the Atlantic, the Sub-Boreal, and the Sub-Atlantic. Okay, so let's start at the beginning. The Pre-Boreal was the first stage of the Holocene, which saw the global temperatures begin to rise. The world had been cloaked in frigid temperatures for much of the last glacial period, leaving a world ecology that was limited by the cold climate. Much of the northern latitudes were very simple ecosystems, with expanses of grassland and tundra permeated with small animals, few grazing mammals, and a handful of large predators. When the Holocene began with this Pre-Boreal period, this increased warmth led to the emergence of forests where there was once just grassland. In the last episode, I discussed the receding forests, and I described how, from the perspective of the expanding grasslands, it was like a 2 steps forward, 1 step back, gradual fluctuation as biomes shrank or expanded. Well, here we can see a fluctuation where the forests are starting to expand a little bit, because the climates are becoming a little more conducive and a little more friendly to larger vegetation. These forests of birch, pine, and aspen trees spread across Asia and Europe. Those animals who already dwelled in the forests, like the deers, pigs, wolves, bears, and large cats, all had their habitats expanded tremendously, and they could radiate outwards across Asia and Europe to find new places to live. Other species, like beavers and otters and various fish, moved into the waterways and the lakes that dotted the surface of Europe. This adaptive radiation created the allopatric and sympatric conditions necessary for divergence and speciation. In addition to the expanding forests, the shrinking grasslands led to the extinction or the displacement of those species that lived there for thousands of years, which only opened up resources and ecological niches for the incoming species that preferred the forests. When the Pre-Boreal period came to an end, it gave rise to the Boreal period. The Boreal period saw humans adapt to the new ecological conditions in Europe and Asia. Many groups adopted the forests as their new homes, using the woods to hunt for meat and gather foods like nuts and fruits, while fishing in the rivers and the lakes for food. The birch and aspen trees that came in the first radiation were now accompanied in the Boreal period by pine trees and hazel trees, increasing the biodiversity of the overlapping regions. The relatively warm temperatures allowed various species to migrate farther north than they would usually have been able, including tropical plants and reptiles that made it as far north as Denmark and Norway. As far as humans were concerned, their forest societies were surrounded by ample resources, and this encouraged a static lifestyle and a shift of attention towards technological production. As the expanding forests moved across the rugged landscape of Asia, they pushed the grasslands eastward. Those large grazing mammals that depended on the grasslands for food were pushed eastward too, and the human populations that hunted them followed their migration. In time, those groups in the central and eastern expanses of Asia had hunted most of their prey to extinction, which forced them to transition from a hunting lifestyle into a herding lifestyle, as they had to manage the remaining populations of ungulates and grazers that they had depended on for so long. Unlike the populations in Europe and Western Asia, these population groups in Central and Eastern Asia were much more nomadic. Instead of settling in regions of high resource density, they migrated nomadically across huge expanses of land, using temporary structures like the Mongolian yurt for shelter. Around this time period 11,000 years ago, and around the geographic region that we know today as Jordan, the first true agricultural societies emerged, where they cultivated figs, dates, and various cereal grains. This area is part of the so-called Fertile Crescent, which is a region of land in Egypt, Iraq, and Syria that stretches from the Nile Delta in the south to Mesopotamia in the northeast, which is a region of modern-day Iraq between the Tigris and Euphrates rivers. As the global temperatures increased in the Pre-Boreal and the Boreal periods, it reached its Holocene maximum in the Atlantic period, which lasted from 7,500 to 5,000 years ago. Because of the relatively warm conditions, the ice caps were small and glaciation was minimal. Because water wasn't tied up in ice, the sea levels were about 3 meters higher than they are today. Because all things are related, all ecosystems were integrated in the global biome, the relatively high water level also increased the general humidity of the atmosphere. This increased humidity and temperature kept the window of opportunity open for more and more plant and animal species to migrate northward. The interactions of the established boreal forests with the incoming species were highly varied, where some regions saw southern species completely take over the habitats, while other regions saw the emergence of mixed forests. In general, hardwood tree species like beech, oak, hazel, and alder crept northward, taking over the softwood pine and birch forests that had moved in several thousand years before. The populations of wolves, deer, horses, pigs, bears, and large cats that had moved north were thriving in these forests, as were a huge range of smaller animals like squirrels, bats, and ground-dwelling rodents. The dominant bird species in Europe were those that hunted by diving into lakes and rivers to catch fish, enjoying the abundance of food in the numerous waterways that covered the continent. In a region of Central Europe between the Danube and Rhine rivers, so kind of around southern Germany and eastern France, a human society emerged that practiced slash-and-burn agriculture. This method involves the literal slashing and burning of forests to clear the land for agriculture. As an early form of deforestation, the slash-and-burn technique was one of the first ways in which humans radically altered their environment and the biogeography of the world around them. By destroying patches of forest, they destroyed all the plants and pushed out all the animals that lived there. Furthermore, the cleared land becomes a suitable habitat for a whole new set of creatures, like those who thrived in the pre-boreal grasslands. This slash-and-burn activity led to a widespread deforestation of Europe, and by the end of the Atlantic, most forests and wooded areas were reduced to small regions surrounded by grassland and primitive farmland. Other human populations in the area at the time were forced to relocate deeper inland, pushed back by rising sea levels. Many human societies of the time were beginning to use pottery, which they left behind in the form of fragmented bowls, tools, and decorations. Groups like the Narva and the Dnieper Donets used pottery, as well as the Central European group who was doing all of this slashing and burning. The Atlantic period has a soft end date. That is, there isn't a hard point where the Atlantic period ends and the Sub-Boreal period begins. This is true for pretty much all of these dates and periods, because it's nearly impossible to date an event or a pattern to a specific year. a lot of these events and patterns take place over tens or hundreds or even thousands of years, so there's a little ambiguity as to exactly when the start and end dates are. Anyways, the Atlantic period gave way to the Sub-Boreal Period, and during this time, the global temperatures began to decrease after peaking in the Atlantic, and with the drop in temperature came a drop in humidity and a corresponding rise in aridity. Many lakes across Africa experienced a rapid drop in water level, as the aridity caused water to evaporate but not get replaced. In the region around modern-day Greece, a brutal drought savaged the people, plants, and animals that lived there. Other droughts would strike throughout the time period, affecting ancient human societies by starving their crops and pushing people to migrate elsewhere. The ancient Mesopotamian city of Uruk is thought to have been brought to its knees by these droughts. As temperatures and humidity continued to drop, the world's forests and biomes underwent significant change. The forests in Europe, particularly northern Europe, suffered from declining elm and oak populations, which returned the dominance in these regions to the softwood birch and pine trees that had originally replaced the grasslands. Other tree species, like beech and hornbeam, experienced the opposite, spreading out with wild success, often to fill in the places left open by the retreat of elm and oak trees. The lowered humidity allowed heath plants, like cranberries and blueberries, to thrive as well, and these spread into Europe and northern Asia. These berries would provide new resources to all of the animals in the region, opening up new niches for them to adapt to, and encouraging the spread of other animals who might use the berries for food. Those insects who used the heath plants for food, or those who used the berries as a place to lay their eggs, those insects would have followed the spread of these heath plants into their new habitats. These insects underwent their own radiation events in symbiosis with the radiation of the plants that they depended on. The Sub-Boreal was a relatively uneventful time, which was followed by the Sub-Atlantic period. The trends of decreasing temperature and humidity continued through the Sub-Boreal into the Sub-Atlantic. The colder temperatures caused many tree populations like oak and alder to recede, while others, like hazel and birch, were able to persist just fine. The expanding adoption of agriculture led to the spread of cereal grains and other domesticated plants, as well as numerous flower species and their associated insect symbionts. The Sub-Atlantic period experienced a few climate fluctuations that had reverberating effects on the ecology. For example, the Sub-Atlantic began with the Roman Warm Period, which lasted for about 600 years, around the time of the Roman Empire. A brief period of cooling followed, which spurred migration among many affected human populations. For example, it's thought that these colder, drier conditions were pushing the Huns further westward into Europe, where they were pushing against the Slavs and the Bulgars, and this would have been a trigger for the migration of Germanic tribes southward into Roman territory, and westward into Spain and Britain. It's kind of fascinating to think that the plethora of Roman wars against aggressive Germanic tribes in the 5th to 8th centuries were caused by the tribes being pushed westward by people invading from even further east, who were themselves motivated to migrate because of a globe-affecting climate fluctuation that had made their previous home just too cold to tolerate. It just goes to show you that a seemingly unimportant detail of geologic history can have massive downstream effects on both biological ecology and human civilization. From the perspective of human civilization specifically, the Holocene can be broken up into blocks of time based on our technological advancement. The first 1500 years or so of the Holocene are part of the Old Stone Age, or the Paleolithic and Mesolithic eras. During this period, and for many thousands of years beforehand, Homo sapiens were outcompeting all of their cousin lineages to become the last remaining lineage in the Homo genus. During this time period, we learned how to fish, and how to control fire. We began rudimentary agriculture by domesticating a few plants and animals, and we developed our first proto-religious philosophies. As our primitive technology developed, we changed our hunting tactics. For thousands of years beforehand, Homo sapiens had hunted smaller, easier-to-catch prey like fish, deer, rabbits, birds, squirrels, lizards, and even bugs. We gathered vegetable foods from the forests and grasslands, like berries, nuts, seeds, tubers, and grains. It was difficult for early man to hunt larger prey, like bison, bears, or mammoth, until we developed a suitable technology. The ancient Clovis culture produced spears with detachable points carved out of bone. The Clovis hunters would approach a mastodon or a bison or some other kind of huge megafauna and throw the spear. The bony spear point would stab into the animal, and as the animal bucked and shook as it ran away, the spear shaft would fall off of the embedded bone tip. The hunter could then recover the spear shaft and load another bone tip for another throw. After killing a huge beast like a mammoth or a bison, the meat could last a village for weeks, or depending on their preservation techniques, for months or even years. As human populations hunted these large animals to extinction, the use of detachable spearheads fell out of practice. Other hunting tools remained popular, like the atlatl in Mesoamerica, and later on, the bow and arrow became ubiquitous in a hunter's arsenal. Humans also came to use dogs to help them hunt. The relationship was symbiotic and very mutualist. The dogs would help track down and attack prey, as they could move faster than the humans. The humans would help kill the prey and prepare the meat, some of which was shared with the dogs, or I should say the wolves, or the ancestors of the dogs, as a reward. This served as the fundamental basis for the co-evolutionary relationship of man and dog. They were loyal companions who helped us get food, and in return, we'd protect them and give them a little bit of the catch. Everyone benefited, so it was a relationship that was preserved as humans became less nomadic and more agricultural. Human groups had to change and adapt to the changing world around them. Peoples who practiced forager lifestyles learned to migrate with the seasons to maximize their available resources at any given time, while those who practiced collector lifestyles tended to find a resource-rich area and stay there for a long period of time. Those who hunted would do so through a variety of means. They would fish in any nearby rivers or lakes. They would make regular hunts for small game like birds, rodents, and deer. And they would dispatch in small groups to hunt down megafauna like bears and mammoths. The development of organized farming and other advanced technologies brought us into the Neolithic, or the New Stone Age, which lasted from around 10,000 years ago up until about 4,000 to 5,000 years ago. The Neolithic saw land cultivation become an increasingly dominant means of food production, which supplemented and then largely replaced hunter-gathering and pastoral herding as the dominant technique. For the most part, human populations were still largely nomadic, dispersed over sizable regions and only connected through trade and shared hunting grounds. But the increasingly popular agricultural techniques led to the Neolithic Revolution, which was a large-scale shift in human lifestyle due to the opportunities provided by agriculture. This began several trends. Human agriculture provided an impetus for technological advancement, as more and more sophisticated devices were created to plow the field, to grind wheat, and to do whatever else was necessary. Second, it meant that humans were living in close proximity to farm animals like cows, goats, sheep, and pigs. They were a source of meat and milk that would influence our human genome. They were also a source of diseases that mutated to infect human populations. And they were also a source of labor that allowed people to engage in large-scale farming and building. All of this, in turn, began a trend of larger settlements, permanent settlements, with larger populations and more specialized divisions of labor. The Neolithic came to an end when humans in the Fertile Crescent developed a primitive metallurgy, which led to a period called the Chalcolithic, or the Copper Age. By this time, people had spread out to every corner of the world, and permanent societies had been established in most regions. Farming was beginning to reshape the surface of the Earth and greatly affect the Earth's ecology, as the practice was being spread across human population groups. More and more land was being cleared for farming, which meant that there was less and less forest for smaller animals, but there was more and more grassland for larger grazing animals. During the Copper Age in Europe, the earliest signs of copper making come from copper battle axes recovered in Serbia. Now, you might have heard the name Otzi the Iceman. This guy is a famous corpse who was found preserved in a frozen mountain pass somewhere in the Alps. He's been dead for more than 4,000 years, which means he lived during the Chalcolithic. On his person was found several supplies and tools, including a copper axe. In the Americas, particularly in South America and Mesoamerica, there's extensive evidence of copper mining and manufacture, suggesting that these people had independently developed copper technology hundreds or thousands of years before most other population groups. In Asia, pieces of copper tools and weapons were recovered in the Jiangxi and Hongshan cultures, which existed in northeastern China. Similar items were also found in India and Pakistan, in Iran and the Middle East, and in parts of Africa. Africa is a little more complex, because individual groups started producing iron while much of the rest of the world was still smelting copper. When it was discovered that tin added to copper can make the superior alloy bronze, the Chalcolithic Age gave way to the Bronze Age around 3,000 years ago. This period saw the rise of numerous major human factions, like the Babylonians and the city of Ur in Mesopotamia, the Moshe and Kalshakwi peoples of South America, and the Harappans of the Indus Valley, the Elam, Oxus, and Kuli peoples in the highlands of Iran, the Hittites and Asua in Anatolia, the Amorites in Syria, the three kingdoms of ancient Egypt, the Minoans and Illyrians of the Aegean Sea, and the Shang and Zhou dynasties in China. Many of these societies knew about each other through trade, where they exchanged wealth, and they also traded with many of the nearby, less advanced societies that surrounded them. Now, just as copper technology was replaced by bronze technology was replaced by iron. This transition wasn't immediate, as many societies continued to use bronze long after other societies had discovered how to use iron. The transition into the Iron Age took place across a time span from 3,000 to around 2,600 years ago. With iron came the associated technological developments and the emergence of continent-spanning factions like the Roman Empire. Human populations began to swell as life expectancy increased, and advances in technology allowed people to farm, hunt, build, and wage wars on scales they'd never been able to before. The impact of human behavior on the world's ecology was really starting to pick up pace, accelerating concurrently with population growth and the development of greater technologies. In the most recent centuries, the world has seen the advent of modern medicine, and then industrialization, and then a global population boom of unprecedented magnitude. In the modern day, in the most recent decades, mankind has achieved a global society with advanced technologies like the internet, genetic modification, and spaceflight. Our influence on the world's biota really can't be understated or underestimated. Within the last 200 years, our industrialization has had an unprecedented influence on the world's ecosystems. We're destroying habitats, rendering countless species extinct, and polluting the oceans and the atmosphere at a rate that's only been surpassed by the meteors or volcanoes that have induced the other mass extinction events in Earth's history. In fact, our modern behavior has been so destructive to life that it's induced the sixth major mass extinction event in the Earth's history, called the Holocene extinction, or more accurately, the anthropogenic extinction. Since the 17th century, species have been going extinct at a faster and faster rate due to human behaviors. Animals like Steller's sea cow, the Meridius blue pigeon, the New Zealand great auk, and the bluebuck antelope were all hunted to extinction. Other animals were also hunted to extinction if they happened to provide some valuable resource to the humans who hunted them. The sea mink was hunted to extinction for its fur in 1860, and the only bear species native to Africa was hunted for sport until they were driven to extinction in 1879. Other species were wiped out when their habitats were wiped out. The Hawaiian chaff flower, the string tree, the platypus frog, the huia bird, and a Tasmanian tiger cousin called the thylacine were all wiped out when their habitats were destroyed by logging, or pollution, or some other human-caused factor. Climate change is responsible for the extinction of species like the 24-rayed sunstar, the golden toad of Costa Rica, and numerous species who use coral reefs as a habitat. Just consider for a moment the sheer volume of activities that we do that can drastically hurt or alter the habitats and ecosystems around us. Our dredging and burning of oil and natural gas is pumping CO2 into the atmosphere, supplemented by the CO2 released from heavy industry, agriculture, and chemical processing. Activities like mining and fracking will often spill chemicals into nearby ecosystems, polluting them and damaging whatever happens to live there. On a global scale, we barely even try to recycle our plastics, which means that millions of tons of plastics are thrown out, only to pollute various habitats with a new exotic material. Animals will mistake pieces of plastic for food and try to eat them, and either choke on the inedible material or starve, as they've eaten plastic until their stomachs are full, and they can't digest it to derive any nutrients, and because their stomachs are full, they can't eat any more food. For that matter, most plastic isn't biodegradable, so when it's thrown out into the wild, it stays there forever. I'll address all of these problems and more in the next and final episode in this series on the evolutionary history of life on Earth. In the next episode, I'll be discussing the ramifications of the Holocene extinction, and I'll explore the future of evolution on our little blue planet. I'll start by discussing how animals and plants have responded evolutionarily to our technology and to our development and urbanization, and then I'll go on to explore the future evolutionary paths that current species might go down. We live in this world surrounded by biology, and our collective behaviors and actions have dramatic effects on this biology. We can see this when we look back in time at the Holocene, and we can predict this into the future by seeing how life responds to us now. If this sounds like something you might be interested in, then you should be sure to come by next week and check it out. As for this episode on the Holocene, I hope I was able to paint a picture of the difficult, rugged lives that our ancestors lived, as they struggled to carve out a place for themselves in a harsh and unforgiving world. If you like this episode, give it a like and share it with your friends. And if you like all my content, then subscribe to my channel for new stuff every week. And as always, thanks for listening.